Okay, so here we're going to find area under a normal curve, and we're going to start off by reviewing the empirical rule. And what I want to do is I want to use the empirical rule to answer these questions, although of finding area under the curve, although I will also go over the TI-84 calculator, which is maybe the method most people want to use anyway. But all right, so let me see if I can provide the empirical rule by drawing pictures. So if I have the normal curve here, here's 0, and this is a standard normal curve. And so the numbers down here are standard units. And it's really, obviously, as you can see, a sketch that I'm doing roughly. Okay, I mean, it's bell-shaped, but I'll try to get something that looks decent, but actually sometimes it comes out better than others. But this region that I'm coloring in right now is 68%. So what do I mean by that? I mean that 68% of the area under the curve lies between -1 and 1 standard units, and the total area is 100%. So I could say the area. By the way, this picture is enough, I think. But anyway, let me write a little sentence. The area between -1 and 1 standard units is 68%. And that's good if you can remember that. I think it's really good. So that's 1 standard unit. Okay, so let me talk about, well, between 2 standard units. So here I have 0, -1, 1, and it's true that my picture might not look the same as this one, but they're supposed to be the same. And if I'm between -2 and 2 standard units, then that is going to be 95%. So the area between -2 and 2 is 95%. This time I left off standard units, but that's what I hope we can understand is going on here. We're talking about standard units. And then the area between -3 and 3 is 99.7%. So that's really almost everything. It's close to 100%, but it isn't everything. So when we were talking about height, and it's every once in a while there's a really tall person, and that person might end up, playing in the NBA because of that. But there are numbers that are beyond 3 standard units to the right or 3 standard units to the left, and that's part of the normal distribution. Okay, so let's then use that. So let's go again first before I move on. 68% is between -1 and 1 standard units, or you could say it's within 1 standard unit of the mean. So this guy right in the 0 is the mean. So, but it's within 1 standard deviation of the mean. This is 95% is within 2 standard deviation of the mean. The one in the mean is the one in the middle. And then 99.7 is 3 standard units of the mean. So let's look at an example. Where we find the area. Okay, so I'll do a bunch of these, but let's just start off with this first one. So find the area between 0 and 1 under the standard normal curve. Okay, I am going to use the empirical rule at first, and then I'm going to show you how to do the calculator. And some people will just be absolutely fine using the calculator the whole time. All right, so what I'm going to do is I'm going to remember the empirical rule, and here I have -1, 0, and 1. Now, why am I picking that portion? Because I have the 1 here. And I know that this whole thing is 68% between -1 and 1 because I look up at that rule, and also I memorize that. Now by symmetry, I can cut this in half, and I'll point an arrow there. Then this is going to be 68% divided by 2, because from 0 to 1, that's half of the 68%. So 68% is that area between -1 and 1, half of that. And then for whatever way you figure that out, that's 4%. So that's what I think is a good way to do this. Now, this method works because I have 0 and 1, and so I don't have fractions of standard units. So I can't use this method from 0 to a half unless I happen to have memorized that. There are tables and there's the calculator to answer that question, what's the area between 0 and a half. But see, what I want to do is use the empirical rule. Why? Because I sort of like sometimes to do things in my head. I'm not carrying around a TI-83 calculator, although, there's probably an app on the phone that I can download if I ever wanted to use that, which would work this out, the area under a curve. It would give a left endpoint and a right endpoint. So that's good too. But I sort of like the idea of being able to do some things in my head. Okay, we'll do more in another video.